Okay, today we'll be beginning chapter 10. 10-1 day 1 is exploring quadratic graphs. Quadratic functions are functions in the form of y equals ax squared plus bx plus c. A, b, and c are going to be A and b are coefficients. C is a constant then because it doesn't have a variable behind it. So some examples of a quadratic function are y equals x squared. Another one would be f of x equals 1/2 x squared, because remember you could use f of x in the place of y and it means the same thing. And the final example would be y equals negative 2x squared plus 6x minus 7. So you notice that in order to be a quadratic function, it has to have an a. For instance, on this one, our a would be a 1, because that's the coefficient in front of x squared. Here my a would be 1/2. Neither one of these have a b and c, and that is okay. It still becomes a quadratic function, but it does have to have an a. On this one, a is negative 2, b is 6, and c is negative 7, so it has all three of them. The standard form of a quadratic function is ax squared plus bx plus c equals 0. So basically it's just a quadratic function that is equal to 0. So to put in all three of these in standard form, you would have the following. X squared equals 0. 1/2 x squared equals 0. Negative 2x squared plus 6x minus 7 equals 0. That makes them all in standard form. The quadratic parent function then is the quadratic function in its simplest form. It could either be written as f of x equals x squared or y equals x squared. Basically that means that the coefficient a is always equal to 1 in the parent function, and b and c are both equal to 0 in the parent function. A parabola, which we have seen before, is a graph of a quadratic function, and remember it creates the U-shaped curve. So if I look here on this one, what we are looking at here are the a's. So my a here is equal to 1. My a over here, remember a is in front of the x squared, is negative 1/4. And if you notice, one opens up and one opens down. Well, if a is positive, it's going to open up. If a is negative, the parabola is going to open down. And it's as simple as that. Okay, the next thing that we need to discuss in vocabulary is the axis of symmetry, which we did not discuss when we looked at parabolas before. The axis of symmetry basically is the line where you could fold it in half and the two matching halves would lie one on top of the other. So for instance here, my axis of symmetry would be, if I can grab it, right here, which would split the parabola in half. So that line only crosses the x-axis, so that means my axis of symmetry would be x equals 1. On my second one here, the axis of symmetry here would be right there. Again, oops, it crosses the x-axis. I should draw it right here at negative 2, and it only crosses the x-axis, so my equation of the line there would be x equals negative 2. Go ahead and turn your page. The next thing we'll be discussing is how you identify the vertex. The vertex of a parabola is either the highest or lowest point. It depends on if it's opening up or if it's opening down. If I look again at this example, a is equal to 1. That's positive, so it's going to open upward. Because it opens upward, this point here would be our vertex, which is the minimum point. So when a is positive, the vertex is going to be the minimum because it is the bottom of the parabola. Over here, my a is equal to negative 1/4, so it opened downward, which means my vertex here would be the maximum because it would be the top. The other thing you will want to notice about the vertices is that the vertex, not sure why that line did that, the vertex always lies on the axis of symmetry. Here it says, when is the vertex the minimum? The vertex is the minimum when A is a positive number, so when A is greater than 0. Okay, and that's because it opens up. It then asks, when is the vertex the maximum? It is the maximum when A is negative, so A is less than 0, and it opens down. The next thing that you're going to be asked to do is you're going to be asked to graph a parabola, and you're going to be able to graph them now without using a graphing calculator. So if I look at this first one here, we have y equals 1/2 x squared. The first thing I would always notice is just get a general idea of what it's going to look like. Here A is positive, so I know then that it's going to open up. So when I graph it, it better open up or I've done something incorrectly. The first step that you need to do is you need to find the axis of symmetry. And I'm going to just call it A of S, so I don't have to write it out, the axis of symmetry. The formula for the axis of symmetry is x equals negative b over 2a. So on this one, negative b, I don't have a b, so b is 0, over 2 times a, which is 1/2. That gives me 0. So I know my axis of symmetry is x equals 0, so it crosses the x-axis at 0. So if I draw it in here, there's where the x-axis is 0. So my line of symmetry is right there. I also know then that my vertex lies somewhere on that line. So the second thing I do is I'm going to be making a table of values. You will always have to put 3 points in your table of values. The first thing I would try to find is I would always try to find your vertex. X is 0 at my vertex because my vertex has to lie on that line of symmetry. If I plug in 0 to my equation, 1/2 times 0 squared is 0. So the point 0, 0 is my vertex. Because it opens up, I know this should be the bottom part of my parabola, and the parabola should go upward. The next point I'm going to try is 2. I'm just trying 2 because that's the denominator, and I'm hoping it'll give me a whole number. 2 squared is 4. 4 times 1/2 is 2. So my next point is 2, 2. My third point I'm going to try is 4. 1/2 times 4 squared. 4 squared is 16. 16 times 1/2 is 8. So my third point here is 4, 8. So by using those 3 points, I got half of my parabola. Whoa, not sure what happened there. Half of my parabola. And it shouldn't even curve back in. It should be going straight. Okay, to get the other side of my parabola, if this is my line of symmetry or axis of symmetry, these points are going to be equal distance from that line as over here. So if I count 1, 2, 3, 4, I should go 4 the other way. 1, 2, 3, 4. Because remember, that green line splits it in half. This point is 1, 2 from it, so 1, 2 from it. And then I'm going to draw the best parabola I can. I'm kind of struggling with this right now. Hopefully I can get it to work. And it should look like it's curved. And there is our parabola. The question here asks, what is its vertex? Its vertex is at the point 0, 0. Is the vertex here the maximum or the minimum? It is at the bottom of the parabola, so that makes it a minimum since it opens up. Go ahead and look at your schedule, or complete your quick checks first, and then look at your schedule for your assignment.